in the packet, but the test format that you said, what can you define more what you mean by an open-ended question?
Sure. Open-ended question is like a part 2 would be think of a multiple choice without multiple choices. Okay. So, and it's not going to be anything like this, but because I'm not going to give away questions on the midterm, but say this is a parallelogram. All right, here's a parallelogram. I'll maybe draw this in here. I'll tell you this is 52 degrees. Let's see. I don't know what I'm trying to make this an honors level, but I'm not off the top of my head. Let's shoot. That's 52 degrees. How else could I do this here? I'll just put it this way. Those two are congruent. Find angle B. Okay, find angle B. All right, find angle. Actually, maybe I'll put the 52 over here instead. And I'll say find angle B. Okay, so you got to know, oh, that's 52. It's across from here, so that's got to be 52. 180 minus 52, 52. So show a little bit more work. Show your work. That's basically what the open-ended questions are. And then once you go into part 3, that might be your construction. All the other questions might be more work needs to be shown. Like this is a part 2 type question. I would classify that as, but part 3 is got to show a little bit more work. Okay. I'm glad Kara brought that up. A reminder, please take your time on the part 1s. I showed you the other day how quickly -2, -2, -2, -2 can add up and affect your grade. All right, especially when you only have 68 points. Any other topics, questions, specific questions you want to go over before we start our review today? Anything. You bring a top. Somebody said nets yesterday. I automatically said don't waste your time. It's not on there. Okay, so if you have a specific topic for me, I'll go over it because I know it's on the midterm, or I'll say, nope, don't waste your time. All right, because we know it's on the midterm. So take advantage of it. Nothing? Okay, here's how we're doing it today. I've decided I'm not going to do questions in your packet. That's your job. That's your job to do questions in your packet in practice. So I need you to get out your Chromebooks, go to Classroom, and you will see the day 2 midterm review. Our big topic today is quadrilaterals. Okay, quadrilaterals. While you're doing that, because unfortunately, even halfway through the school year, I still don't trust some of you being on the correct site. So we're going to lock it down here. So please go to Classroom. You'll see midterm review day number 2. And let's apply a scene here to everybody. There we go. And you can do what you want. You want to do it right on your Chromebook. You just want to watch. That's fine too. All right. If you want to jot down notes while I'm going over these, that's fine too. This is your midterm, guys. This is your midterm. Please just don't come back to me on Monday. Oh, I wonder why I did so poorly on this when we didn't do any preparation to begin with. All right. That's the last thing I want. And I don't know if I went over yesterday. Just because you're a 90 student in quarter 1 and quarter 2, the midterm doesn't care. This is a fresh start for everybody. All right, the midterm is fresh for everybody. It does not matter how you performed on quarter 1 and quarter 2. What does matter is the effort you put into preparing for it. So there are a significant amount of quadrilateral questions. All right, knowing your properties. I don't want anybody to be scared here. I just couldn't find a updated chart. We didn't do kites, so you don't have to worry about kites, right? We didn't do kites, but everything else is fair game up here. So what I want to do is go through this chart, and first thing I want to do is check off which property applies to which polygon. Okay, which property applies to which polygon. So let's go first here. Both pairs of opposite sides are congruent. Everyone ready? Both pairs of opposite sides are congruent. Parallelogram. Yes or no? Yes. So I automatically know if you said yes to parallelogram, you should be saying yes to everything else in that family, which includes rectangle, rhombus, and square, right? So if you're saying a parallelogram has it, automatically so do the rectangle, rhombus, and square. How about the trapezoid? Trapezoid, both pairs of opposite sides congruent. No. How about isosceles? No. Okay. It does not have both pair. Does not have both pair. Diagonals congruent. Parallelogram. No. No. Rectangle. Yes. Rhombus. No. Square.
Yes.
Yeah. You check any of these before it. It's going to have it. Trapezoid. No. Isosceles trapezoid. That's a yes. Remember that. Diagonals are congruent. Diagonals perpendicular. Parallelogram? Nope. Rectangle? Nope. Rhombus?
Yes.
So that must mean a square. How about the trapezoid? No love here. Isosceles trapezoid? Nope. Bisect each other. Parallelogram? Okay, so that means also rectangle, rhombus, square. Trapezoid? Nope. And how about isosceles trapezoid? I heard a yes there. Yes or no? Diagonals bisect each other in an isosceles trapezoid? No, they're only congruent. They're only congruent in an isosceles trapezoid. Consecutive angles are supplementary in a parallelogram? Yes, they are. Trapezoid. Be careful. Some consecutive angles are. Ready? Be careful when you say that. D and A are. C and B are. Those consecutive angles are. But what about A and B? Nope. D and C. So not all consecutive angles are supplementary in a trapezoid. Just two pair. Just two pair. And the same goes for isosceles trapezoid. Okay, the base angles are equal. All right. Both pairs of opposite angles congruent. Parallelogram? Trapezoid? Nope. How about isosceles trapezoid? Nope. Okay, nope. So that's it. Okay, we good there? Any questions going over one more? I got one more thing here with the properties. Okay, quite a few questions on quadrilaterals. All right, here we go. Part 2 here. Name the quad. Name the quad given its property. Both pairs of opposite sides are parallel. Can we do it without looking back at the chart? What do we got? Parallelogram. Rectangle. Rhombus. And the square. Opposite sides congruent? All of them again, right? All of them again. I'm just trying to remind you guys by doing this that if you're going to tell me it's a parallelogram property, it's got to be a property for the other 3 in that family. Both pairs of opposite angles congruent. And that would be the entire parallelogram family. All right, maybe we'll get a little confused now. Exactly. One pair of opposite sides is parallel.
Trapezoid and isosceles trapezoid.
Trapezoid and isosceles trapezoid. And you can cross out number 11 because that was a kite, number 11. Exactly one pair of opposite angles. That was a kite's property when we used to do kites back in the day.
Wait, will we learn kite this year?
What?
Will we learn kite this year?
No, you're not. No kites this year because remember, you guys are taking the new version of the geometry, right? Just like Algebra 1, and kites are not included in the new version. So that's why they have been eliminated from the course. All right, anything? Properties before we go algebra. All right, let's buckle up. First one, rhombus, A, B, C, D, find X. Find X. I've given you A, D, B, C, and I'm looking for A, B. All right, so we went over a bunch of properties from the parallelogram family. What are A, D, and B, C? What am I giving you? The lengths of it? A, D, and B, C, those are the what in the rhombus? Those are the diagonals. They do a lot in the rhombus. They do a lot. And I got to get to a side, A, B. So what are you going to fill me in? Diagonals of a rhombus.
They bisect each other.
Bisect each other.
And they're perpendicular.
Perpendicular, they do more, but those are the two I'm going to use right here, that they bisect each other. So AD is broken up into 5 and 5. BC is broken up into 7 and 7. And you told me they're perpendicular. I believe this is one of the formulas I threw up on the board that you're going to need to know, which is Pythagorean theorem. Yes. When you use Pythagorean theorem, only in a right triangle, A and B are the two legs that make the right angle, and C is the hypotenuse. What are those 5 and 7s? A, B, or C? 5 and 7 are A and B. Yep. And we'll leave it in simplest radical form. Okay, we'll leave it in. Yes, Sophie.
If it doesn't tell us which one to leave it in.
Oh, it will. It will. I'm not going to pull any guessing games with you guys. All right, it will tell you how to leave your answer. And here's the other thing. If it doesn't, and you're looking at a radical or a whole number or a decimal, you probably did something wrong because there was no rounding directions needed. Okay? Yep, that's also a big thing. A kid raises their hand and I come over. What should I be rounding to? And I hate to break it to them that there shouldn't need to be any rounding. So go back and get to work. All right, next up. Hey, we got a rhombus again. Nice. We got a rhombus. What is angle X up there? That's 70. I gave you 70 was BDA. How about angle X? All right, let's throw some properties out, see what sticks to the wall here. How am I going to get to angle X, knowing that that's 70 and that is a rhombus? Anything else we want to fill out here? Anything else you're confident in? Jacob, what's one thing?
All 4 angles in the middle are right angles.
Okay, then we can start there. All 4 angles are right angles. There it is. Yep. So that's a right angle test. Going to keep adding to my diagram. DBC. Okay. You may not do it this way, but we're doing this as a group here, so I'm just following your lead. This has to be 70 because alternate interior angles, excuse me, are congruent. All right, and I'll put all the angles were right angles, so I better put one there. So is everyone seeing how I could find X now? Based on where we are right now as a group, I could say X equals 180 minus 90 minus 70. So X equals 20. Kira, going back to your question earlier in class, this could be a part 2 question. It definitely could be a part 2 question. Also, nobody said it, but I want to remind you of another property of a rhombus. Diagonals perpendicular, they bisect each other, and they bisect the angles. Okay, they bisect the angles. All right, so just a reminder there.
Well, we have to show work on the part 2, right?
Yep. You will have to show work in pen, unless it's a graph. We good? Ask if you got anything. All right, let's go to an isosceles trapezoid. Find angle POM. And I'll let you know, the problem should have told you, but NO and MP are the bases that are parallel to each other. Find POM. POM. Again, another part 2 level question right there. And it's an isosceles trapezoid. Anybody want to fill in my diagram with more angle measures maybe? So I can eventually get to POM or PON? Or not? Any other angle measurements you're confident in up here? Go ahead, Kara, let's go.
P and O is 28.
Okay, alternate interior angles are congruent. Great job. That's 28. And I'm looking for POM. POM somehow. POM. Zach, talk to us.
Oh, well, like the bottom angles are congruent.
Base angles are congruent, correct. So angle OPM, which if I add that up real quick is what, 70? Is congruent to angle NMP, which is 70. Base angles are congruent, yep. Keep going here with me. Jacob, keep talking.
PON would be 110.
This up top here would be,
Yeah, the big
yep, 110. Both of these would be 110. How did Jacob get to the 110? If these are parallel, these are same side interior angles. They're supplementary. All right, we're getting there. We're getting there. I need to get to POM. Let me mark that in green. How am I getting to that angle, huh? We're almost there, kids. We're almost there. Oh, what's up, Tess?
Is NOM 28 degrees?
Say that again.
NOM.
28? How do you know that?
Because if the angle on the bottom, if the base angle is like congruent.
Yep.
And doesn't it form an isosceles triangle?
What triangle?
I don't know. And I don't know.
Remember, when I say 70, I'm talking this whole angle is 70. This whole angle is 70, right? I just don't know where your isosceles.
So if OMP is 28 degrees.
OMP. But that would mean that this is isosceles.
Yeah.
And how do I know those are equal? Is my question. No, diagonal's congruent. That's it. Diagonal's congruent. That's it. Ooh, we got some honors level questions here. Let's go down.
So the same side interior angles are supplementary.
Yep.
So if angle OPM is 70, then NOP will be 110 degrees.
Yeah, which we got there. We're looking for POM though. Right? We know PON is 110. We're looking for POM, this one right here that I marked. Okay, and I don't know if it's getting bisected or not. Kira?
I don't know if it helps, but PNM is 42. Same side. Not same side, also interior.
Well, hold on. Okay, hold on. So you want me to add 42 here, right?
Yeah, just add it in.
Be sure you want me to put 42 there because, again,
Oh, yeah,
it's not alternate interior because these would need to be congruent. But I can find that angle because I know it adds up to what? It has to add up to 110. Go ahead. It's got to add up to 110. Keep going.
So then you do 110 minus
Yep, which would be
82.
82. Yep. Ooh, I like it. Abby, what's good?
Isn't OMP 28?
How do we get that?
When we were talking about isosceles trapezoids for the first time, didn't you say that the diagonals form two isosceles triangles?
No, that is a rectangle. In a rectangle, the diagonals form 4 isosceles triangles.
Oh,
Yep. Just diagonals are congruent here. That's it. Diagonals are congruent. What's up, Kara?
Couldn't you say that NMO is 42? Or no? Like that it's like broken up the same way as the other big angle or no?
What are we talking about?
Like that NMO would be 42 with it.
M and O,
Yeah.
where I have the 82 and the 28.
No. Whenever, like right below that one. NMO.
Will?
You have to find triangle NPM and OPM congruent.
Well, hold on.
Because
Name those two triangles again, Will.
OPM and MP.
OPM, this one I'm going to highlight, right?
Yeah.
With which one?
NMP.
NMP. Oh, that's probably not the best color. We're saying those are congruent.
Yeah.
What's your reason?
Base angle is congruent, and then reflexive, and then the two that are congruent. The because it's isosceles.
No, MP is reflexive, so you get the one side and the two. So.
Okay, here you go. Everyone see the two I just highlighted up there? Everyone agrees the legs are congruent, right? NM congruent to OP. Base angles and an isosceles trapezoid are congruent, so everyone see the angles and everyone see the reflexive side MP. So by side angle side, they're congruent. CPCTC would say my angle I'm looking for, POM, would be congruent to which corresponding angle? MNP, which we already know is 82. There you go. Woo-hoo-hoo! There it is. That problem is called a wake-up call. A wake-up call. Maybe I'm not as good as I thought I was, type deal. Okay. Everybody good there. Nice job, young buck. Good work. We all good. Like I said, what did I tell you at the beginning of class? Some you're going to just breeze through by. Some you're just going to breeze through by. Some you may have to take a little bit more time or maybe come back to. All right. All right, 11. Now we got a parallelogram Fred. This is one you might be able to breeze through. I don't know. We'll see. AF congruent to DF. Angle R is a buck 24. What about angle AFD? Not as tough as the last one, but still got to know your stuff, right? What other angles am I going to know here? Abby, give me one angle we know.
FRE is 124. Or sorry, FDE.
FDE is 124. Opposite angles in a parallelogram are congruent. Let's keep adding more angles to this diagram. Gauge.
FDA.
Yep.
56.
Linear pairs are supplementary.
And so is FAD.
Angle A is also 56 because in a triangle, congruent angles are across from congruent sides. And now, angle AFD, 180 minus 56 minus 56. 68 degrees. Happen. Like, there you go, right? I'm just trying to give you a little taste of what to expect on Tuesday. And do I have anything else here?
Yeah.
Yep, one more. What's the measure of ADE? Really doesn't have much, I'll be honest, doesn't have anything to do with quadrilaterals, right? But 180 degrees in every triangle, every time, all the time. Jacob, want to start us off here with an angle?
Angle E is 45.
Angle
DEC.
DEC is 45. Yep. If anybody's wondering where Jacob got that from, triangle, ABE, the big one, already has a right angle and it already has 45 degrees at angle A. And all of them got to add up to 180. So he's like 180 minus 90 minus 45 gives me angle E, which is 45. All right, we're almost there. ADE, I think we can finish this right now if we're looking in the right spot. Gage?
I'm just saying right now that ABC is congruent to BCE.
ABC and BCE because of angle, side. Sure, yep. You're right there. Angle, side. Those two triangles are congruent. Zach? I think we can find ADE right now.
120.
Why?
Because 180 minus 15 minus 45.
Everyone see the triangle I'm looking at there? How many angles do we already know? 2, 15, and 45. So now we can say angle ADE is equal to 180 minus 15 minus 45. And what did that end up? That's 120 degrees. Now, do you have to get it that quick? No, nobody's putting a time crunch on you there. It doesn't matter how you get it as long as we end up with 120. Maybe you found a couple other angles. Maybe you found that angle and did supplementary there or vertical. Okay, other different ways. Yep.
You have said that angle ABD equals 90 and then angle BAD equals 30 and then added those to me.
And got 60?
Yeah.
And then supplementary. Yep, there's another way to do it. Still get 120. Anything else? Okay, here's my suggested problems for tonight. Take it or leave it. Your call. Again, why am I suggesting these problems? Well, something topic-wise definitely will be on the midterm. There you go. There you go. I could have said, hey, just do all the quadrilateral problems, right? Because that's what we just went over. But I've selected certain quadrilateral problems for a reason. So those are the ones I'm suggesting tonight. And we don't need to pack up. We still got plenty of time here, kids. We still got 11 minutes to work. Quick question, just so I don't put one on your desk at the midterm. Is who is planning on bringing their own NumWorks calculator to the midterm? Just keep your hand up there. Then again, the only reason I'm asking is because I don't want to put one on your desk and waste time coming around.
What if your thing dies midway through?
What?
What if your thing dies midway through?
You better charge it. Mine will be charged. All the calculators you get from the school will be charged. I guarantee that. And remember, you guys with your hands up, I'm not coming around to clear it, nor do I expect you to clear it either. So just bring it and get going. Good. Lucy, Catherine, good. Abby, good. Gage, thank you. Adia, thank you. Jacob, thank you. Chia, thank you. Who else I got here? Melissa. Zach. And Bennett. All right, thanks, guys. I just won't put one on your desk. Thank you. You got yours, Will? Okay, thanks. You're gonna bring it, Melissa? Okay. Thanks, guys.
Wait, there's no 45. Like, or 52. I'm mixing with you.
What?
Yeah, there is. Yeah, there is.
Page 52. Page 45. Page 45, page
I
52.
think your things are small.
Oh, wait.
No, what he's saying is that none of the questions
Are you in the right
answered
packet?
Oh, no. Okay. Oh, here's it.
Make sure you're in the midterm review packet. I got my act together and got the pages correct now. I'm good. Tomorrow we'll go over triangle facts and any constructions you want me to do. All right, triangle facts and any constructions upon request you would like me to do.